functions. We're going to do writing quadratic functions in models. This would be applicable for the application of quadratics. We go out, we gather data, we take that data, and we plot that data on an XY graph representing whatever it is that we're looking at. Maybe we're a company trying to maximize the volume of our containers, but we want to minimize the surface area of the material that we use. In terms of the surface area portion, or maximizing area part of a problem, we would create problems that are quadratic in nature. So we're going to figure out how we can do that. How do we take the data points that are on the graph and come up with the equations, because the equations are what I would then use as modeling for future scenarios. So we're going to take a look at each of our forms. The first one we're going to do is our quadratic into a vertex form. So a reminder on our forms, refreshers on this. Vertex form is our A quantity x minus h squared plus k, where hk is our vertex. H is our axis of symmetry. All right, when we write our equations in the vertex form, as with the other forms, we're going to leave y and x as y and x in our equation. We do want to fill something in, however, for the a value, for the h value, and for the k value. Well, we look at the data we have on this graph. We've been given 2 points. We might be able to interpret, although we would be guessing, but we might be able to interpret that point as at 0, -1. And by reflection, that would probably be a pretty good guess. All right. We take those 2 points, though, and we come up with our equation. Now, what we recognize here is that with this graph, we see we have an upside-down parabola. That immediately tells me my a is going to be negative. But more importantly, we've got this point that appears to be at the very top of this curve, which means this is my vertex, which means I know my h and k. So we can fill that in. So far we have y is equal to a times x. Okay, now my h, my coordinate is a -2. And if I'm thinking about the negative of a -2, because I'm saying x minus h, so if I have a negative of a -2, that really becomes plus 2. And then plus my k, which in this case is a 3. So I simplify this so far to become a x plus 2 quantity squared plus 3. Now the problem is we still don't have a value for a. Well, that's where these other coordinates are going to come in. So we had -4, 1. And that is an x and a y value. So I can use those coordinates and plug those values into our equation. So I can take the -1 and plug it in for y. And then I'll have equals a times. And then I take the -4, which is my x, and I plug that into my equation. And from here, we're able to find the value of a. Hopefully it's negative. So we get -1 is equal to a times -4 plus 2 squared plus 3. Go ahead and move that 3 to the other side. Square that -2. And we get that a is -1. Now that we know what a is, we can then therefore state our equation as y equals a times x minus h, where our h was a plus 2 squared, and in this case, plus 3. So there we are in vertex form, given those 2 coordinates on that graph. Right, as with previous examples, I'm going to run the first one through, and then if you want to try the other ones on your own, this would be a good place to stop the video and then come back and check your answer in just a second. So we're going to do B now. No graph to look at this time. I can still see, though, that I have a vertex. So I know I have H and K. And then I have my X and Y values that I'm going to plug into my equation. So we're supposed to start with writing the generic formula. Now we will replace all of the appropriate variables with the values I've been given here. So my Y is a 5. A I don't know. X is a 1. My H, which is a negative 1. And my K, which is a negative 4. So 5 is equal to A times quantity of 2 squared. And I get 9 is equal to 4A, and therefore A is equal to 9/4. So I have a vertical stretch here of 2 1/4. We now go and rewrite our equation once we find A. So therefore, my equation would state Y is equal to A X plus 1 quantity squared minus 4. And we'll just go ahead and do the last one here real quick. Once again, identifying what I've got. Y is equal to A, X minus 4 quantity squared plus 2. Plugging in my Y's and my X's. Negative 4 is equal to negative 6 squared, 36A plus 2. My A this time is negative 1/6. And therefore, my equation is Y equals negative 1/6 X minus 4 squared plus 2. So there's a few examples of running given points into vertex form. And the key with those, again, was I was given, as one of the coordinates, the vertex of the graph. Big clue there that I'm going to write in vertex form. What about the other forms? How about intercept form? Well, first of all, refresher on intercept form. This is the one that I get to see the x-intercepts. There's the equation Y equal A quantity X minus P, X minus Q. And remember that P and Q are your x-intercepts. And so I have x-intercepts. Doesn't really matter which one you call P, which one you call Q. And just like with our H, when we were writing our equation for vertex form, I'm thinking of the opposite values when I'm plugging these things in. Okay, we also have been given, again, a point that could be useful to me. So we start out with the generic. We plug in what we know. So I have a Y value of negative 4.5. Don't know A. An X value of 3. A P value, the first one is a negative of a negative 4. So we're going to be adding that 4. And then an X, which again is negative 3. Plus or minus 0. So negative 4.5 is equal to negative 3 plus 4 is 1. So 1A times negative 3 is negative 3A's. Divide by negative 3, and I get A is 1.5. Therefore, Y would equal A X minus P, which means I get X plus 4. And then X minus 0, I can just write it as X. Because that's what I'm going to simplify to. And there I can leave my answer in intercept form for that problem. This would be the pause time if you want to try this one on your own. Plug in our x-intercepts. Plug in my y's and my x's. Go ahead and simplify this. On the right-hand side, we get 1 times negative 4, or negative 4a. And then a would equal 1 on this one. Therefore, y would equal, now my coefficient is a 1. I'm just going to leave it. I don't have to write 1. And I'm just going to go ahead and write my intercepts in here. And there you are with the intercept form. Once again, dependent on the information I've been given. So this is probably not necessarily hard, just a little more work involved with this. Writing ourselves into a standard form given 3 points. Now, it might be good for you to kind of sketch the graph with the points that you have, just so you can get an idea of maybe if my graph is opening up or down based on the points I have. That would be a good check for my a value. So if my a is positive, I'm going to open up. If my a is negative, I'm going to open down. Standard form, again, a review, ax squared plus bx plus c. Now, in the other equations, we were filling something in for all of the other variables except for y and x. I have to write my equation, that's what I want to do. So that means I got to find a, I have to find b, and I have to find c. Real quickly, just kind of thinking about this graph, kind of a very quick sketch. Negative 230, that's way up here somewhere. 1, 6, that's right over here somewhere. And then 4, 36, that's up here. So I kind of get an idea that my graph is doing something like that. Now maybe it is going to go down and eventually hit that x-intercept somewhere. But for right now, I just know that my graph is going to open up based on those 3 coordinates. I cannot interpret any of those as being vertex or, well, obviously none of them are x-intercepts because I don't have any coordinates where the y values are 0. None of them are y-intercepts because I don't have any coordinates where the x value is 0. So we just go with what we have here, and we're going to have to set up a triple system for this. So we'll work with equation A first. Equation A starts with the generic, and what we do is we use the points, and we're going to use point negative 230. And those again are my x and my y's, and I'm going to plug those into this equation here. So I get 30 is equal to a negative 2 squared plus b times negative 2 plus c. Simplifying all this, we get 4a minus 2b plus c. And this is what we will call equation A. And we're going to do this now for each of my points. So each of my coordinates. That's equation A. Let's look at B. I'm going to have, we're going to use 1, 6 for this one. So now I'm going to have, again, I'm just going to fill right in. Y equals ax squared plus bx plus c. 6 is equal to a plus b plus c. So there is our equation B. Then we use point 436. This will be equation C. Doing the same thing. Y equals a x squared plus bx plus c. 36, 16a plus 4b plus c. And now we have our third equation. So we have our 3 equations, A, B, C, each having 3 unknown variables. And so for our system to work, we have to have 3 equations, and that's where we have the ABCs are. That's what the ABCs are for. And if we remember from when we were doing the solving a triple system in chapter 3, what we did now is we start to pair equations together and choose to eliminate a common variable. So we're going to do that now. I'm going to pair equation A and B together. So A, once again, is 30 is equal to 4a minus 2b plus c. And B is equal to 6 equals a plus b plus c. Now, it makes sense because my c's are kind of obvious in terms of their coefficients being 1. I'm going to just go ahead and choose to make 1 I'm doing this is because I'm trying to get these C values to become opposite, to cancel them. Now I chose C, but it's not wrong if you choose to eliminate B or if you choose to eliminate A. You just have to decide which variable makes more sense. Probably in these standard equations, makes sense to just get rid of that C value because there's no coefficient we have to worry about. All right, I'm then going to look at this, kind of ignoring that one. We rewrote it. And I have 30 minus 6, 24, 4a minus a, 3a, negative 2b's minus b, minus 3b. This now becomes my new equation. We'll call it D. I will then choose two other equations. I used a and b last time. Maybe we use a and c. So I still use 30 is equal to 4a minus 2b plus c. I could use b and c as well, just as long as I'm doing two different equations. All right, we're going to use a and c. C is 36 is equal to 16a plus 4b plus c. And once again, I'm going to multiply this negative here through for equation c, and it becomes negative 36, negative 16a minus 4b minus c. And then I'll ignore that. And then we'll go ahead and add up the columns here. So 30 minus 36, negative 6. 4a minus 16a, negative 12a. Negative 2b's minus 4b's minus 6b. This we will call equation E. Notice that equation A, or D and E, are both in terms of just two variables now, A and B. Now we have a double system that we set up. So we're going to take equation E, we're going to put it on over here. Negative 6, negative 12a. Remember when you're solving these systems by the elimination method, you want to line up the proper numbers in their position. So the constants line up, the a's line up, the b's line up. Okay, I look at D and E, and right now I can't eliminate A or B without having to change one of the equations. I'm going to choose to take equation D, multiply it by a negative 2, so that I cancel the b's in this term, or in this case. So negative 24, or 24 times negative 2 is negative 48. 3a times negative 2 is negative 6a. Negative 3b times negative 2 is plus 6b. So I'm opting to eliminate my b's here. Again, negative 54 is equal to negative 18a. And dividing by negative 18, we discover that a is equal to 3. Now it's a domino effect. I have A, I will then now go find B. So I choose to plug A into either equation D or equation E. Not both, just pick one of them. So I'm going to go ahead and work with equation D here. So we have 24 is equal to 3A minus 3B. And we're plugging in A of 3. Plugging that in, this equation would then become 24 is equal to 3 times A, which is a 3, minus 3B. 24 is equal to 9 minus 3B. Subtract 9. 15 is equal to negative 3B. Divide the negative 3, and B is a negative 5. All right, we now have A and B. So then we choose either A, B, or C, our original equations, and we plug in to go find C. Since B is pretty darn simple, I'm just going to choose that one. But I would either do A, B, or C. And plug I'm going to use equation B. And equation B was 6 equals A plus B plus C. 6A plus B plus C. And we're going to take the A and replace it with a 3. Again, that's coming from right here. And then we're going to take a B and we're going to plug it in. We get 6 equal to 3 minus 5 plus C. 6 is equal to negative 2 plus C. C is equal to an 8. Now that we found all of our unknowns, we can make our standard equation. Y is now equal to ax squared